Arun Kumar,
Sir.
is it audible
Yes,
now?
yes, sir.
Clearly?
Audible. Yes, sir.
Okay, we'll start now. Can you see that paint window now?
Yes, sir. Wind is visible, sir.
Okay. Okay. Good morning, everyone. Today we are going to see the syntax directed translation scheme for declaration statement. Right. Now we'll see that declaration statement. Arun Kumar, please interact with me, right?
Okay, sir. Okay, sir.
Okay. Now you see that one minute. Okay. Syntax directed translation scheme for scheme for declaration statement. Okay. Here, now you see this one in C language, we are having the declaration statement as end A, comma, B, comma, C, and then we are having comma C, and then we are having colon. A, comma, A, comma, B, comma, C, and colon. Semicolon. Here, A, comma, B, comma, C, and semicolon. And then we are having now float, F1, F2, or something. Yeah. Then character C. Then we are having now that character. So, right. If you are having that array, right? So if you are having a pointer, then we are having now int star A, star P, int star P. Right? If you are having an array, then we are having now int A of 5. Then we are having now that two-dimensional array or multi-dimensional array A of 5, comma 5. We are having A of or something. A1, this is A2 of that, right? Now we are having now, this is a declaration statement. Okay, in C language, we are having this a declaration statement. Now, for that, we consider we are having a grammar, right? So that is, we are having now the statement is of type declaration statement with the semicolon at the end, right? Now, here the declaration statement like that. Here, first one is type, then, sorry, type. We are having now, this is type, that data type, key, and then we are having now the list of variables, TL. Then that T is the type. So we are having what are the types are there. So T may be integer and T may be float and T may be character. Right. So whatever type we are having, we can add it. Next we are having now that TL. Then we are having L. L is actually a simple variable. Here we are having now L is list of, right? So that is L1 comma ID. So we can have now any number of IDs we can have now. Then here we are having now this is a single type variable. Then we are having this is the list, right? If you are having that array type variable, right? That is L derives. We are having now that ID square bracket, right? So here we are having now L derives. So L derives. If you are having that array, E list square bracket. So L derives E list E list square bracket. Then here we are having now that L derives L E list square bracket L derives. Then we are having now that one as a E list close bracket, and then E list is E list. So that is E list E list derives E list square bracket and square bracket E. And then we are having now that E list is ID plus E list bracket ID square bracket. Right now you see this one. This is the list of production rules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we are having for pointer, right? So that is here we are having now the 11th one is that L as L derives star ID. This is for point. L derives star ID. Right? Is there anything else missing? Anybody? So these are all the declarations, right? So by variable declaration is this one. Now how we have to go far we are going to see that. Clear?
Yes, sir.
Okay, D is declaration, one single declaration only, right? Then we are having now D is list of declaration. Okay, accept. Sure. Right. Now you see this one here integer end A comma B comma C, right? Now how we are going to have that one as here yes there is D colon for that case, right? So that is we are having now the D is a type and then L. This L is here we are having now symbol variable L derives L comma ID. L comma ID. L1 comma ID. Then this is we are having now L1 comma ID. ID, right? Then we are having now another one L1 comma ID. L1 comma L directly ID. So only 3 variable. So L comma ID in that case. L1 comma ID. The T is integer. Right? End A comma B comma C. So that one is here. End A comma B comma C and semicolon. So this is for first statement, right? This is for first statement. Now, actually, what action we have to take is here you have to make an entry for variable A, right? So that is here in that symbol table. In the symbol table, we have to put an entry as the data type is here we are having the name of the data ID is A, and then name of ID, and then type. The type is integer, and then we are having now that offset. Offset is here we are having type is integer and single type single, and then we are having offset. Offset is the in the data segment where is that particular variable is or particular ID is allocated. So here is a array of memory. In that array of memory, the A is going to be placed. Here we are having the starting address of the data segment. From the data segment, we have to add the offset. Then it will find out the location of the corresponding variable address. So this is the case, right? So what we are having now in the symbol table, what is the ID name, and then what's the data type, and then we are having now that offset. The offset is here, this offset distance, right? Then we are having the address of the location A. Similarly, we are having for B also we have to make an entry. B, this is integer, and this is then we are having that offset. We are adding that offset. It's another offset, right? So that B is here. So for the B, we are having that offset is some then added with that. This is offset. Then for B, we are having that location. And then for C, we are having now the next consecutive location. C and so on, right? So if you assume that four byte, right? Each one is, or each integer, if you are having 4 bytes, so it will allocate 4 bytes. Right? So this is offset, right? So suppose we are having this starting address. So offset is initially offset is 0. Then B offset is 4. and C offset is C integer, then offset is 8. So from the starting address, the data segment plus added with that offset. So this is A and then B and C, right? Then here we are having this next one as float. Float type is here we are having now F1, F, right? So that one is here we are declaring the statement, right? The statement is declaration statement. Then we are having now that one as here D is here we are having TL. That L is T is a float. Then L is L, there is L comma ID. This ID, then this is ID. This ID is F1. This ID is A. So this is a declaration statement, right? Now for that we are having now, then it will make an entry. F1, then this is float type, and 8 plus 4, then we are having now 8 plus 4, 12. So 12 is here. Now if you assume that one float is 8 byte, then next cases as F2, then this is float, and then we are coming 8 for 12 plus 8, the offset is 20. And so on, then it's going now, right? Next we are having now the C. C is C1. Okay, C1 is already C is there. So if you are having already C, then it won't allocate, it won't tell that one, it will give that error. So you have to give the another variable C1, right? The C1 is character, right? Now in that symbol table, so in that consecutively you are having the symbol table C1, the character type. Then we are having now that offset is 20 plus 8, 28. Offset is 28. So here from this location, the 28th byte we are having now C1. 28 byte we are having now the C1 in the memory, right? Then here like next integer star p. Integer star p. Star p is pointer. So the pointer is we are having only 4 bytes. So that one is here. We are having now that this is p. Then here we are having now that this is the integer, right? Then here you have to now integer pointer. So this is integer p, and then we are having now that one as we are having now this one as integer pointer. Integer. Then here we are having the one more entry as this is a single data type. This is a pointer data type. Then if you are having array data type, like we are having one more entry, then the offset is here, the pointer 28 plus 1, 29. So the 29 is here for P. And then we are having that A. So for that we are having now, this is A is 5 into 4, 20 bytes block of memory is allotted for A1. So A1 is here, A1 as integer, then this is array type. Then here we are having now that offset is, here we are having that 29 plus 2, 31 offset, right? Next one is we are having 31 plus 20, 51. So the offset is 51 for the next ones, A2. A2 is integer, then array, we are having that offset is 51. So that one is 5 into 5, 25, 25 into 4, 100, right? So that is here we are having, it will allocate the 100 block of memory in the, right? So 100 size of that bytes allocated for A2. Allocated for A2. The starting address is here we are having 51. The 51 byte, right? So the offset is 51. In the offset 51, we are having that A2. The A2 is having that some set of this. Clear? Anybody is having doubts, you can ask now. Then we are going to write that semantic action for the declaration statement. Arun Kumar?
Clear, sir.
Is clear now?
Yes, sir. Clear, sir.
Okay, I will give that another 2 minutes. Anybody else, if you are having doubt, you can ask. So you are having now, if you are declaring a variable, for that declaration, it will allocate the memory and it will make an entry on the symbol table. Sorry, in this meeting. Right. Shall we continue further? Okay. Now we'll see that one. What actually what semantic action we can add it for make an entry, right? Now, for our, okay, I see that. This is now. We take the copy. Okay. Especially on TTL. Right here, we are adding one more statement as T derives T1 semicolon D. So this is we are having many declarations, right? So declaration type, if we get the statement declaration, we can have a list of declaration. Otherwise, we can go for yeah. Now, here what actually we have to do is, initially, we are having that offset is null. Initially, we are having now offset null. Yeah, what is the best? Offset, right? So offset is null. So initially we are having offset is 0. Null is 0. You will see that instead of null, I will put now 0. Offset is 0. Initial is. So next we are having now the T colon with the T. So many declaration statement. So we are having T colon with the D. So that one is here. We are having now, this is T type. Nothing is there, right? So here we are having now the declaration statement. All right. Next we are having now, for that you don't have anything. Now here we are having now the T derives L, right? So here we are having now as we are having the declaration statement as T. Then we are having L. The L is we are having now L derives ID. L derives L comma ID. Then this is L derives in 1 second and L comma ID. Like that, right? Now here we are having now that attributes we have to add that type, right? So this is D, the D is integer. So here we are having that attribute is T dot type. So the T dot type is T dot type. What type it is? Actually integer. So we are getting now the type as integer here, right? Next one, here we are having now width of that memory. So width here is an integer. So T dot width is 4, right? Then we are having now this this attribute as T type is inherited to the L. So that is L inherited attribute is equal to T dot type. What do you mean by inherited attribute? I will tell them. So we are having two types of attributes. One is called inherited attribute. Then another one is synthesized attribute. Synthesis. Attributes. We are having two types of attributes. So what I mean by that one is, if you are having the root and then we are having the attribute, we are getting the, for the child, the attributes we are getting now, this is called actually inherited attribute. Right? So this is a parent. Then here we are having now sibling 1, sibling 2, sibling 3, sibling 4, right? So that is here, if you are having, we are getting that one attribute, S3 from parent or its left child. Attributes we are getting now from parents or its left child, right? So that is here heritage, right? As like the heritage, the parents characteristics is coming to the child. Like we are having now, if you are deriving the attribute from the parent or it's a elder sibling. Elder sibling, we are getting now the characteristics. So that is called inherited attributes. Next one, synthesized attribute is from the child, we are getting now the two parent, right? So far, we have discussed the synthesized attribute. So E derives E plus E. E derives E plus E for that one. So we are having now the attribute is E dot place equal to E1 dot place, E1 dot place plus E2 dot place, right? So that is here, this attribute and this attribute. These two are from the child. So child attributes, from the child attributes, we are synthesized the parent attribute. So that is called synthesized attribute, right? The inherited attribute is here, we are getting the attribute of a child from its parent or otherwise elder sibling. Elder sibling, right? This is in the right hand side, we are having now younger sibling. Then here we are having elder sibling, right? So the attribute of that one particular child, we are getting now the attributes from parent, right? Now you see this one, here the attribute of the L, we are getting now, attribute of the L we are getting now from the T. So it's left child. So this is a left child. T is a left child. L is right child for the parent D. So we are having that attributes, right? So we are getting the attributes from the left child to that, right? Next one, here we are having now the L inherited, right? So here L1 inherited also we are getting now from the L1 inherited is getting from L dot inherited. They are getting the attribute, this one from the parent to child. So that also inherited attributes we are getting now, right? So that is what you mean by that one, as this integer, if you are declaring that variable as int a comma b comma c, right? So that is int a, int b, int c. So all are integer type. So we are getting the attributes by, so the theta type is integer. Then this integer is, we are carry over to this L, and this integer carry over to L, then carry over to L, right? So this is this L is we are getting now the inherited attributes. So attributes we are getting from here to here, and then we go for. So the attribute is integer. The integer is passed on to this this ID, and this integer is passed on through L this ID, right? Then this for that last ID also we are getting now that attributes from this child. So this is called inherited attributes. So suppose they may ask question about the inherited attribute and synthesized attributes. You have to give the difference between inherited and synthesized attributes. So you have to explain that, right? Now here we are having, this is actual requirement, and then here if you are having that ID, right? So this ID, so what we are having now, that one is in that L derives ID, we are having now here we are having that offset, right? So this is the ID. ID is here we are having now the L derives ID. We can have now. So it will make an entry. So this is case. Here we are having L dot type and L dot offset, right? So L dot type is actually L dot type is here we are having now single variable, right? Then here L dot inherited as T dot type, right? Then we are having now L dot offset. Offset is here we are having now this the width of that one, right? So this is actually L dot offset. Offset is a variable. Then here we are having the offset is added with L dot width. So what is the width of the variable? Width of the variable is added with that offset. Then we are getting now the offset. Okay. L dot offset we are having now. Right, then here we have to make an entry, right? So for this L we are having now, it will have that add entry. We are having now that one add, we are having now add entry. And entry means in that symbol table we have to make an entry, right? So entry is id dot name, and then we are having now the L dot type, L dot inherited, and L dot type, and then we are having now offset. Already we are having that offset, right? So this is an entry we have to make for this L derives ID. So here this is a function. Add entry is a function. Add entry is a function. Then this function is going to create an entry in the symbol table. So in the symbol table, here we are having now that the id dot name is here A, and the L dot inherited attribute is here integer. L dot type is here we are having now the single variable, and then we are having now that offset. Right? Then here we are having now that offset is one offset is over, then it will add that offset. So offset, then L dot offset is added with. So this offset is here we are adding now offset with L dot offset, and here we are having now the width offset plus width. L dot offset right? Width. Then here we are having now. Next, we are having now this is L1, right? So this L dot offset is here we are having this one. Once again, then L derives ID is going to make that L, right? Now here what we have to do is then L dot type and everything is there. L dot be inherited and something is there. And then we have to add the offset, right? So that offset is equal to then offset now. Like you are adding that one. So this is, we are having, initially we are having S derives ID. S derives is equal, right? So in that, here we are adding offset is null. So the offset is null, here 0. Then here we are adding 4 bytes. Then here we are adding 4 bytes. Then next one is here we are having now that 4 bytes. So the offset is 4 now. Then by this way we are adding another 4 bytes. So 8 offset. So this is 8. Then offset is going to have that one as 12. Right? The 12 is carry over for the next declaration. The 12 offset is 12. Then it will continue now that one as another declaration. So here we are having now the t dot offset is, here we have the t1 dot offset is equal to d dot offset we are getting now. So offset is added, carry over to the offset in t. So we have to continue. So that one is here, the t dot offset is equal to L dot offset. We are having now that one. So this offset is carry over, then we have to do that. I will once again write that one. So here we are having now d that is t1 over t1, sorry. Right, okay. We are having now the 2, 3, 4, 5. So we are having that number is changing now, right? 2, 3, 4, 5, 6. So now here we are having now the initially we are having now the attributors. So we are having one variable we are using now. The offset is a variable. The offset is initially we are having 0. Offset is 0. Next we are having the declarations. So here we are having now the t dot offset equal to d1 dot offset, t1 dot offset. So we are making a call offset, right? This is the reason. Next we are having now the d there is t, right? So here we are having now the t dot offset is equal to L dot offset. So we are making a copy, and then we are having now the t dot type, t dot L dot inherited, right? L dot inherited attribute equal to t dot type. So what type it is? And then we are having now L dot inherited, and we are having now L dot offset is here L dot, so offset equal to T dot type. Okay, T dot is L, T dot type, integer, anything else you have inherited, L dot inherited. And E dot, T dot type. So next we are having that integer. For that integer, we are having now the T dot type equal to integer. T dot type equal to integer. And T dot width is 4. Then for float, we are having now T dot type equal to float, and T dot width is 8. Then here we are having now the character type. So the T dot type is equal to type is character, and T dot width is, we are having now one byte. Next we are having now this one L derives L1 comma ID, right? So for that, what we need to have that one is here L dot of L1 L dot offset equal to L dot offset, not offset equal L dot offset equal to L1 dot offset and plus L1 dot width. So here how many number of width we have to, right? So here we have to go for, before that we have to make an entry, right? So that one is here. We are having add entry with ID dot name. Then here we are having now ID dot name, and then we are having now ID dot L dot type, L1 dot type, or L1 dot inherited, and L1 dot type. So that L1 dot inherited is L1 dot inherited from L dot inherited. Right. Right. So for that, what we have to is L1 dot inherited attribute from L dot inherited. So we are getting now the type inherited, right? Then here we are having now that L dot type integer. Okay. Then L1 dot type is, we are having a single variable, means here we are having now the corresponding type, right? So L1 dot type is, here we are having now L dot type. And then we are having now that one entry is add entry with ID dot name, and here we are having L1 dot inherited attributes, and L1 dot type, and then with the offset. Right now the offset is, we are going to add it with offset equal to already existing offset plus now that L1 dot width. So what's the size of that variable? So this with this added with the offset, right? So the offset is once again we are adding now. Next one, L derives ID. So L derives ID. So where what we are having now, that one is L derives ID, right? So that is we are having now add entry with ID dot name, comma offset, right? So here we are having now that offset is, here we are having now L dot width. L dot width equal to the integer type, means here L dot ID. So that is L dot inherited. L dot width is right, L dot width equal to Therefore, so just we are making an entry only, right? Offset. Now here we next one is t dot t integer. T is integer. So for that we are coming out this one t dot type and the t dot width. So the t dot width is added, right? So the t dot width is having that n dot. Offset. T dot width equal to n dot. N dot offset. Right. Then we are having now. This is we are having now that for entry for that array, right? So for that array, then what we need is you have to multiply that e, right? So here we are having now a equal to 5 and something. Then what we are having now? So 5 is multiplied with 5 and 5 is multiplied with 5. So we are getting now the total 5 into 25. Then 125 into width of that each element, right? So with that d dot width. So we are having now the total byte is allocated for. So with this here we are having integer 4. So we are having around 500 bytes are allocated. So we are having that we are adding that offset with 500. So it will allocate the memory for 500. Right? So for that we have to write, right? The last one here we are having now for LDRIS ID, where we are having now as here we are having that add entry in the case. Here we are having now the ID dot name, and here we are having now that one the type is the data type is here we are having now integer. Then here integer means L dot type, L dot inherited, and then we are having now it's a pointer type, PTR type, and then we have to add offset. Right now here we are adding now L dot offset is added with offset plus 4, offset plus 2. The 2 is here we are having now offset is already we are having that offset. Then here we are having now that L dot offset, and then we are having now that already we are having what's the offset. Then we are having added with that one. Then we are having that offset value is this one, right? Right. Okay. Now how do you calculate? We'll see that. Fine. So with that one. C equals now we are having now L there is E list close bracket. E list close bracket. Then we are having now L there is we are having now that E list there is. Right. L there is E list. E list square bracket and L there is so E list there is E list. E list there is E list square bracket then E list ID square bracket. This is an array, right? So how do you we can calculate now the sizes here? We are having now that initially we are having now that offset, right? So that is we are having now the E list. We are having now the total width, right? So here we are going to start now, right? So that is here offset equal to here E list. Then we are having now the E. What's the value now? E dot place. E dot places we are having now some number, right? That number is added. So this ID is a type. Then we are having now, this is E dot place. So you have to create a temporary variable T equal to new term. Then we are having now that T equal to new term. Then we are having now that E dot place, E list dot place. E list dot place is equal to, and already we are having E dot place, E list dot place multiplied with that E list dot place. Right? So this content and this content is multiplied. So we are getting now the E dot place. Like we have to go for the first index, second index, third index, and so on. At the final, then we have to calculate now the what is that E list dot place. The E list dot place, we are having multiplication of that all dimension and multiplied with that L dot width. So we are getting now that one. So the total L dot here we are having now the offset. Total offset we are having calculating now that one, right? So already we are having one offset is there. So we have to add that one. This T equal to that one. Then we have to add offset. Here we have to make an entry, right? So here add entry, that is closed. Add entry with that type is here we are having now that array, right? So ID dot name, the array. Then we are having now this one as here ID dot name, and then we are having now L dot inherited, and then we are having now this is array type. Then we are having now this is offset. Now the new offset is offset L dot offset is here we are having already existing offset plus added with the current the calculation, right? So E list dot offset, right? So here we are having now the E list dot offset. So we are adding that offset, then it will go up. So what we are having now, the E dot place. Okay. E dot place is equal to E dot place is some value, right? So that is equal to E list dot place. So E list dot offset. E list dot offset equal to E dot place. Then we are having that one is multiplying now. So E list dot place itself. Place and sorry. Here we are having now E list dot place equal to E dot place. Right? Then E list dot array, E list dot name is ID dot name. So then one we are having now here also E list dot place, E list dot name is equal to E list dot name, and then here ID dot name, like here E list dot name. So once again I'll write that one. So I write it clearly. First case, L there is E list okay, right? Then here we are having now the offset calculation, right? So that is here we are having now the here L dot offset. So L dot here first we are having now L dot offset is here we are having now E list dot place, E list dot place the content into the here L in dot with L dot width. So what is the width of the each element we are getting now, right? So that is we are having that offset now we are calculating. Already we are having now this L dot attributes. L dot width. We can have now add an entry here. Add an entry for that one E list dot place. E list dot place. And then we are having now that E list dot places, we are having ID. Then we are having the type is here, we are having L dot inherited type. And then we are having now that this is array type. Right? Then we are having now, this is the offset. Now the new offset is calculated now. So E list dot place into width. So that one is plus added with that already we are having that offset is there, right? So plus you have to add already existing offset. So we are having now the new offset is we are calculating now. new offset is we are calculating, right? Then we are having now that E list derives E list square bracket, right? So here we are having now the E list dot name, E list dot name is, here we are having now that the E list 1. So E list dot name equal to E list 1 dot name. Then we are having now that in that E list dot place, E list dot place equal to already E1 list of place multiplied with, right? So that is we are having now that each and every index we are having now the multiplied. Then at the final you have to close it, right? So here you are going to start. So that is this, right? So these are all the this will be there removed. Right? So this is the case we are having now, right? That the L derives E list square bracket. Then for that we are making an entry, and in the E list dot place we are having the name of that ID. Then we are having now that the inherited attribute is the type, integer type or float type. We are getting now integer type or float type. Then this is a array type variable. So that is here we are having the type of variable is array, and then we are having that already existing offset we are having, right? Then after getting that, so here if you are having that one array as a of 5, 5, 5, right? Then here you are calculating now that one as, here initially we are having, this is the case, right? So that is ID. So this ID is a. So that the variable name is a. ID dot place okay, ID is name, right? So that is E list dot place is equal to E dot place. So E list dot place E list of ID dot name is A, E list dot place. Then E list dot place we are having now that first index, right? So first index 5. So 5 is here. Then we are having now here what we are having now, that one is next here, right? So this is E list of name is A. Then E list of name is A once again. Then this variable for that we are having now getting from here. So E list 1 dot place equal to E list of place. So E list of place name equal to E. Then E list of 1 dot place is equal to, already here 5 is there. Then we are adding that this E dot place. In that E dot place we are having another 5. So 5 into 5 we are getting now the 25, right? Then 25 we are getting now that one as E list of place. Then once again then this is repeated now for next case. So here we are having now the close now, right? So that is here we are having now E list of place. Once again then 5 into 5, 25. Now the 25 is here, 25 is here, and then we are having multiplied with 5, 125 we are getting now. This 125 we are carry over here, right? So E list of place is A, then inherited attribute is type integer, then this is an array, then offset is already existing offset, right? So where we are having now, this is already existing offset we are having now. Then after that we have to calculate the offset, right? So that is 125 multiplied with that weight, so that multiply 125 500, right? So suppose already we are having the offset is around 100 is there. Now the 100 is added with the 500. So this is 500 plus 100. So 600 is offset for the next coming declaration. So that is 500 is allocated for this array. This is A for 500. So A with the size is 500 bytes. Then this is already the 100 bytes or something is there. Then 100 plus 500, 600 is the next coming declaration offset. By this way, we are calculating the offset and allocate the memory. So the add entry is we are having allocation, right? So here we are having now that allocation add entry, and we are having now the entry, and then we have to move the offset through the offset moving. Then we are having this memory is allocated for that variable A. Clear?
Yes, sir.
Any doubts, Arun?
No, sir.
Okay. Anybody else? If you are having doubts, you can ask now. Another 10 minutes, I will be here. Yeah, if you don't have the doubts, then we can put attendance and you can leave now.